packet, the examples, so you guys could finish it up. So this next one, I think we had finished this polynomial one in class, but now we have a trig one, so I want to kind of talk about that. Now they use a theta instead of an x. So as the x was before, now it's a theta. So when we find f prime of theta, remember the derivative of sine theta is cosine theta. So I'm going to get 4 times cosine theta. And then the derivative of theta is just 1, because remember, this is like having an x, and the derivative of 1x to the first power, remember the derivative with respect to x was just 1x to the 0 power, which would just be 1. So the derivative of this, because we're doing the derivative with respect to theta, you just get 1. So that's my derivative. So then if I want to know f prime of pi over 2, I'm going to plug in a pi over 2, so I get 4 times cosine of pi over 2 minus 1. And cosine of pi over 2, remember that's the top of the circle. The coordinates of that would be 0, 1. Remember cosine then would be 0, so I get 4 times 0 minus 1, which is just negative 1. So that's the slope of my tangent line. Then I need to figure out what f of pi over 2 is. So I'm going to have 4 times sine of pi over 2 minus theta, which is pi over 2. So sine of pi over 2 at the top of the circle, the sine value is 1. So I get 4 minus pi over 2. So this is my y value. So remember, we're after this, the equation of the tangent line, y minus y1 equals m times x minus x1. So now I have all the pieces, so I'm going to take y minus, and this is going to be kind of strange, we're not going to simplify it either, 4 minus pi over 2, because that was like my y value, equals the slope that I found. The slope of my tangent line was negative 1. And then we have x minus the value pi over 2. And I mean, we could simplify that, but we're not going to. I'm just going to leave it like this because it's y minus y1 equals m times x minus x1. Okay, so on the next one, we're going to start by finding g prime of theta. So the derivative of 2 theta, remember we're taking the derivative with respect to theta. Just like before, we took the derivative with respect to x, and it's just 2. And here we get the derivative of cosine is negative sine, so I'm going to change this to a minus 3 sine theta. So that's my derivative. So then if I want to find g prime of pi, I get 2 minus 3 times sine pi. So sine of pi, remember pi is here. The coordinates are negative 1, 0. Sine is the y coordinate, so we get 2 minus 3 times 0, which is just 2. So that's my slope of my tangent line. I needed to know g of pi to get my y value. So we have 2 theta, so 2 pi, plus 3 times cosine pi, because I'm just plugging this into my original function. So I get 2 pi. Cosine of pi is negative 1, so that's going to make this a minus 3. So that's my y value. So y minus y1 equals m times x minus x1. I've got all the pieces now. I'm going to have y minus 2 pi minus 3 equals the slope that we found was 2 times x minus the value, which was pi. And we're going to leave it like that, and that's what we get. On this next one, I know what happens after a while. It's like you breathe a sigh of relief. Oh, no trig. Really, it's not that bad. It's just kind of getting used to, if you're using a different variable, if you're using a theta, which a lot of times we do for angles instead of an x, not a big deal. So here, what I want to do first is get this into a kind of a polynomial form so I can use that rule, the power rule. So we're going to have h of x equals, I'm going to think of this as x, remember this is a square root, so I have x to the 3/2 power. We got the power is 3, the root is 2. I'm going to put a 1 right here just to help. So if I subtract the exponents, I'm going to get, if we take 1, which is 2 halves minus 3 halves, is negative 1 half. So this is what I get for my function. So then if I want to find h prime of x, I'm going to do the that product rule, or the power rule. So we're just going to multiply negative 1/2 times 2. So I get negative 1. And then x to the subtract 1 from that. So we get negative 3 halves. So that is my derivative. Now keep in mind what this means. Sometimes it's convenient to switch it back to the original format, or to radical format. So it's negative. It's going to be in the denominator because a negative exponent, and it's the square root of x cubed. So sometimes it's convenient to kind of put it back into that format because we're going to be plugging in a number in just a minute, actually right now. We need to know h prime of 2. So I get negative 1 over the square root of 2 cubed, which is 8. And we can simplify this. It's okay if you left it the square root of 8. You don't have to simplify that, but we know that there's a perfect square in there, 4 times 2. So you get negative 1 over 2 root 2. So I'm going to leave it like that, but it would be okay if you left it. So that's the slope of my tangent line. So now I need to know h of 2 so I can figure out the y value. So I'm going to plug a 2 back in up here to what I have originally. And actually, I'm going to plug it into this part right here where I simplified it a little bit. So we would have, because this is just 2 over the square root of 2. I'm sorry, 2 over the square root of x. Let me change that. This right here is 2 over the square root of x, because x to the minus 1/2 would be the square root of x, but flip to the denominator. So when I plug in a 2, I get 2 over the square root of 2. Then now I'm ready to put that into my y minus y1 equals m times x minus x1. So we have y minus 2 over root 2 equals, my slope was negative 1 over 2 root 2 times x minus 2. And I'm going to leave it like that. So that would be the equation of my tangent line. Again, notice what we're doing in all these cases. We're finding the derivative, plugging in the value to find the slope of the tangent line. Then we are plugging in the value into the original function to find the y value, so that we have all the pieces to write the equation of our tangent line. On this next problem, it says, given the equation of a function, how might you determine the value or values at which the function has a horizontal tangent? Explain your reasoning. So if we have a horizontal tangent, well, the fact that it's horizontal, if you think about, I paused to turn my mail off. If a horizontal tangent, think about like this horizontal line, has a slope of 0. So that means that our derivative, because remember the slope of our tangent line is equated to our derivative. So how we can find the values where the function has a horizontal tangent is by taking the derivative. If my function is f of x, then if I take f prime of x and set it equal to 0, that's going to tell me where, because this represents the slope of my tangent line. So I want to know when the slope of my tangent line is 0, because that tells me the horizontal tangent. So we're going to set the derivative equal to 0. So, and you'll see these questions a lot too. So at what values of x will the function f of x equal x cubed plus x have a horizontal tangent? Well, if I want to know that, then I want to know when is f prime of x equal to 0. So that's the question. When you see something asked about finding horizontal tangents of a function, you're going to take the derivative and set it equal to 0. So f prime of x is 3x squared plus 1, using our rule. So now if I set that equal to 0 and solve this, I get 3x squared equals negative 1. X squared equals negative 1/3. So x equals plus or minus the square root of negative 1/3. Well, there's no real solutions. There's no for this. So my answer in this case is there are no horizontal tangents for this particular function. Okay, so there aren't any values where there's a horizontal tangent since I couldn't get an answer there. So this next one, I think the last one, at what value or values of theta at which the function, okay, there's some bad grammar in there. F of theta equals theta plus sine theta has a horizontal tangent on the interval from 0 to 2 pi. So we've got to find the values where there's a horizontal tangent. Well, horizontal tangent means if I take the derivative, and this time we're calling the variable theta, f prime of theta equal to 0. So I have to find f prime of theta. So this is with respect to theta. So in this would be like when we had an x. So the derivative of theta is just 1. The derivative of sine theta is cosine theta. So I want to take this, if I'm looking for horizontal tangents, then I have to take the derivative and set it equal to 0. So if I subtract 1 from each side, I get cosine theta equals negative 1. Now think on the unit circle. For what angle value on the unit circle do you get a cosine value of negative 1? So remember, this is 0, pi over 2, pi, 3 pi over 2 on the unit circle. The cosine values, sine and cosine, are going to be 1 and negative 1 or 0 on the quadrantal angles. So remember that at pi, we get negative 1 comma 0 as the ordered pair. So cosine is the first coordinate, the x-coordinate. So theta would have to be pi. And that fits within the interval because they're asking us just on the interval from 0 to 2 pi. So that would be 1 trip around the unit circle. So this is my answer. So at which value would you have a horizontal tangent? At theta equals pi. Then you'd have a horizontal tangent. So that should do it for the rest of this packet, which means you guys should be able to do the homework that was on page 141 to 144. Give it a try. If you have questions, we can go over some questions in class on Monday, but do your best.